Hello and welcome back to another video by Johnny. Okay, I knew I said that several times, but okay, I should think of some beginning line, a better beginning line, intro. That's what I call it. Okay, so in this episode is episode 6. It's episode number 6. I know, I should have done this episode before the previous one, which is quantum number. But a friend of mine just needed so much. I mean, he needed help in quantum number, and I think that quantum number is more closely linked to the orbitals and configuration, electron configuration, which is in the first and the second episode. So that's why I did it before this one. So in this episode number 6, I'll continue with the naming, but now it's a naming of inorganic salt. What is inorganic salt? Basically, a salt is a metal and a non-metal combined together. I mean, inorganically. It should have a metal part and a non-metal part in there combined together, just like yin and yang combined together, Or it can be the result of a base combined with an acid. So a base and an acid together. So if you haven't watched the naming video in episode 3 and 4, I think the number 4, right? Yeah. Episode 4 is about naming acid and bases. So if you haven't watched number 4, please go and watch it now. Okay. Because the episode number 4, it talks about naming of bases and salt, and that is the foundation of the salt. So please go watch it now. Okay, if you have done watching it, then we can continue. Alright, so I have prepared for you a way to name them in a more fun way and challenging way. So first of all, let's try to name these cations and anions that made up the salt. Pause the video and try to name them, please. All these cation and anion. That's right. So what are these things called? It's a manganese 2. It's a manganese 2. How about this one? Yes, it's a copper 1. It's a copper 2 ion. This one? It's a lead 2 ion, because we have lead 1 as well. Okay, how about this one? Yes, it's a chromate ion. This one? It's a dichromate ion. Okay, with that being said, I'm sure you have you can name all these anion and cation if you have watched the episode number 3 and 4. So now let's come to the next part. Can you try to write this chemical formula? Please just pause the video and try to do it yourself. Okay, now let's try. Okay, so what's the answer for here? Potassium nitrate is KNO3. Potassium nitrate. How about magnesium chloride? Magnesium and chloride, right? But how about their charge? Their oxidation number? +2 here, -1 there. So it has to be number 2 there and 1 down there. 1 we don't even write it. Okay, iron 3 sulfate. How do you write it? Iron 3, so +3, and sulfate, SO2, SO4 is 2 minus. So number 2 will be here, and the number 3 will cover the whole sulfate. Remember, we treat them like one species. SO4 like the whole species of chemical species, like one thing. So if SO4 is 2 minus, it's going to end up here, and 3 down there. Copper 1 phosphate. phosphate is 3 minus. Very good. Number 3 gonna be here. And number 1 gonna be for phosphate, which we don't even need to write down. Zinc chloride. Zinc 2 plus, chloride 1 minus, so it's gonna be 2 here. Sodium hypochlorite. Remember hypochlorite, chlorite, chlorate, and perchlorate? Yes, that are these things. Sodium hypochlorite is ClO. Aluminum bromide. Chromium 2 chlorate is Cr chlorate, right? ClO3, and this one is actually going to bear number 3 as well, because chromium 3, right? Chlorate is 1 minus. Silver iodide. Calcium sulfite. Remember the difference between sulfite and sulfate? They're just one oxygen bigger, smaller than each other. So calcium and sulfite, SO3. Chromium, so chromium 3 carbonate, Cr plus 3, and carbonate is CO3 minus 2. So you have to have 2 here and 3 there. 2 CO3, 2 minus, 2 here, 3 there. So lead 2 dichromate. Lead 2 dichromate is a Cr2O7, 2 minus. So 2 minus here, 2 minus there, so 1-1 ratio. Okay, good. Do you get the same result? Okay, you should get the same result here. Otherwise, try to recheck the charges of them, okay? Now, let's come to part B. Can you try to provide their IUPAC name, the IUPAC name? Okay, so from the chemical formula, you should write their name down. Pause the video, please, for 18 examples. Okay. This one is gold bromide. Barium phosphite. Phosphite, okay, because this one is not PO4, it's PO3. Barium phosphite. This one is cobalt chloride. Sodium bicarbonate or sodium hydrogen carbonate. Potassium dichromate. Lithium carbonate. Silver carbonate. Titanium nitrate. I know titanium has titanium 2, titanium 4, yeah, but I think in this case titanium 2 this is titanium 2 nitrite because it's NO2 minus, not NO3. So titanium 2 nitrite. This is lead what? Okay, this is lead 1. You can see here, 2 and 1 here. This is lead 1 chromate. Lead 1 chromate. This one? Titanium 2 sulfate. Gold chloride. Potassium permanganate. This is MnO4 minus, is permanganate ion. So sodium sulfide. Sodium sulfide. Aluminium hydrogen carbonate, or you can call them aluminium bicarbonate. What copper is this? It's copper 1, you can see here. Copper 1 hypochlorite. Copper 1 hypochlorite. Remember, chlorite and chloride is different. One is a T, one is a D, and it's a different thing. How about this one? It's iron 2 fluoride. This one, potassium chlorate. This one is copper 2 perchlorate. Alright, so let's come to the next part. Can you guess which acid and bases that combine to create the salt above? I mean, all of these salt. Can you guess which acid and bases that combine to create them? To create the salt above? Like, for example, let's look at this case. This case number 3. Iron 3 sulfate. What acid and bases will form them? You should go from their formula or from the names. So iron 3, it should be like iron 3 hydroxide as a base, and the acid should be sulfuric acid, or you can say hydrogen sulfate. You go. From the name, you can just say iron. This part is metal, so it's going to be the base part. This one is acidic part. So iron 3 hydroxide is a base, and hydrogen sulfate is an acid part. Remember when I told you how the acids are named? I gave you 2 different naming systems. So I use hydrogen sulfate and sulfuric acid. So both names are equal. But I think the hydrogen sulfate is a better system to learn. Now you understand why. So hydrogen sulfate or sulfuric acids and iron 3 hydroxide, okay? How about this one? Yes, it's sodium sulfide, right? So NaOH, sodium hydroxide, and H2S, hydrogen sulfide, or we call them sulfur hydric acid. How about this one? How about this one? Silver iodide. Okay, it should come from silver hydroxide and hydrogen iodide, or we call it iodhydric acid. Iodhydric acid. Hi and AgOH. Okay. How about this one? Yes, it's chromium 3 hydroxide and H2CO3, hydrogen carbonate. But to be honest with you, it cannot be created that way. Because why? H2CO3 is a weak acid. It will not really react to form this thing. So we'll have to do it another way. I mean, theoretically speaking, it can be formed from these acids, but practically, no. Okay, how about easier cases? This one. Yes, it's copper 1 hydroxide and hydrogen phosphate, or we call it phosphoric acid. Phosphoric acid. Alright. How about this one? Yes, it was made from copper 2 hydroxide and hydrogen perchlorate, or we call it acid perchloric acid. Okay, I'm sure you can practice more on your own with these acids and with these salt. Okay, but to shorten the video a little bit, let's go to the last part. Can you try to write down the oxidation numbers for all of these atoms, all of them, in all the species, ions and salt in this whiteboard? That will be your homework. Just write down all the oxidation number like what I do. All of them. That will be your homework. Okay. I hope the video was helpful for you. Please like, subscribe, and share my video. As always, all the information can be found in the video description. The video description down below this video. Okay. I hope the video was helpful for you, and see you in episode number 7 and 8. Yeah. Bye. See you.